Welcome dear students. I am Dr. Divakar Mehta, Assistant Professor from Carmel College of Arts, Science and Commerce for Women, NUMEM. The name of the program is Bachelor of Science first year, subject Botany, semester 2, course code BOC 102, course title Biodiversity 2, which includes vascular plants. Title of the unit Biometrics, Numerical Taxonomy and Cladistics. Module name Character, Weighting and Coding. In the previous module you have studied about what is biometrics, numerical taxonomy and also characters, variations and OTUs. Broad outline of this unit. First we will have a short introduction. Then we will learn about character weighting and character coding. At the end of this module, you will be able to recall the character weighting and character coding. Also will be able to describe the character weighting and character coding. Once the OTUs are selected, listing of all the available characters is to be done. And there should be not less than 60 characters that we had discussed in the previous module. And more than 80 characters are always desirable. So you will get a better result. All the available characters may be listed in a tabular form as shown below. This is the table. So you can see operational taxonomic units are in the first column 1, 2, 3, 4, 5 and various characters, that is habit, habitat, leaves, pollen, carpels, this nature of these characters are given here. So each row will show the different character status for each operational taxonomic units. There will be OTU1 which will be a hub, whereas OTU3 if you consider it is a UD. Like that you will find habitat. Fourth OTU is a aquatic plant. Like this, in this tabular column you will find all the characters of selected operational taxonomic units. Character coding. All such characters what I showed you in the tabular form, a computer will not be able to recognize them. So what we have to do, before we feed the data into computer, we have to suitably code them. Coding of character is done by assigning plus and minus or 0 and 1 sign will be used. Here 0 does not indicate absence of a character. It is just a character state 0 or 1. Usually positive character are recorded as plus or 1 and negative characters as 0 or minus. In case if it is possible to distinguish, we have to try to find out which is plesiomorphic character and which is apomorphic character. I will come to these two terms in the next slide. And multi-state characters are coded as 0, 1, 2, 3, 4. For example, flower color you take. It will have different colors. Yellow, white, blue, green, like that. No, green very rarely you will find. So we have to give different code like 0, 1, 2, 3, 4. Whereas wherever there is the character state is only 2 state, then you can give 0, 1 or positive and negative. Character weighting. More commonly in numerical taxonomy, there will be equal weightage for all the characters without considering whether it is a plesiomorphic or apomorphic. But when you want to do phylogenetic analysis, these characters should be tried to assign some weightage. Character weighting is the assignment of greater or lesser taxonomic importance to certain characters over other characters in determining phylogenetic relationships. An ancestral character is called plesiomorphic character, and such character is given less weightage. For example, you will find there are aquatic plants and terrestrial plants. In the evolutionary process, aquatic plants are more primitive than terrestrial. So, aquatic plants are the ancestors of terrestrial plant. So, what we will do? We will consider aquatic plants as the plesiomorphic character and terrestrial as the apomorphic character. Same way what we do for the plesiomorphic character, we will give 0 and apomorphic character we will give 1. Here is the table with few examples for these apomorphic and plesiomorphic character. For example, you see habit. Habit character state is woody or herbaceous. Here woody is plesiomorphic character, whereas herbaceous is apomorphic character, because in the evolution woody plants are the ancient one and the herbaceous plants are more recent. So what we consider woody as the ancestors and herbaceous plants as the more recent one. So we will give 0 code for woody plants and 1 for herbaceous. Same way habitat, aquatic and terrestrial. Aquatic are ancestral and terrestrial are more recent. Leaves, simple one are primitive, compound one are more advanced character. Same way carpels, free are primitive or ancestral character and fused carpels are more advanced. Accordingly, we will give the weightage. Once you do such coding, we have to prepare a matrix, that is character into OTU matrix. The coded data may be organized in the form of a matrix or table with T number of rows and N number of columns. So such matrix is very important for the numerical taxonomy. The character and OTU matrix supplies the data for constructing phenogram and phylogenetic tree or cladogram. So without such tabular matrix, that is character into OTU matrix or OTU into OTU matrix, we will not be able to do the numerical taxonomic analysis. Once the data has been codified and entered in the form of a matrix, the next step is to calculate the degree of similarity and distance between every pair of OTU. What we will do? We will try to find the similarity between pair of OTU, and also you will try to find the difference between the pair of OTU. It is a elaborative work where you will be learning in the higher classes. Now I am not going to explain these things, but you can see one example of tabular column where you find the OTUs and character matrix have been shown here. So in the first column you will find the operational taxonomic units. 5 hypothetical taxonomic units have been considered here, and the character coding also is done. You can see the habit, whatever it is, the character state woody or herbaceous, and according to the plesiomorphic and apomorphic character the weightage has been given, and accordingly the coding has been done here. So in this module we have studied character coding and how the character weighting is to be done. These are the references. Thank you.